Hi, this is Mr. Coombe. We are finishing off this problem from the last video. In the last video, we figured out a couple of different things. We figured out how far the ball travels, considering that there's no air resistance from the base of the tower. So we found out that it traveled 756.6 meters. And we also found out how long it took for it to actually fall to that distance away. So in this problem, we have the tallest tower, Burj Khalifa, 828 meters tall, and we have the man who has the fastest kick recorded, fastest soccer kick, which is 58.2 meters per second. So now we're actually going to figure out the displacement in this particular example. In this next video, I'm going to explain how to find the final velocity in the example. So first things first, we know that the displacement is going to have a magnitude and direction. So the displacement is going to be something like this. So it won't be the same as the motion. It'll be just a straight line. So if we have, whenever we have straight line in trying to figure out a straight line from two dimensions, we can use Pythagorean theorem. So very easy. So we know that the person's, let's put this in purple, their displacement in the y direction being down, we know that it's 828 meters down. And we know that their displacement across in the horizontal component is 756.6 meters. So we're going to know that the displacement of the ball is going to be to the bottom right. Okay, to the bottom right. So let's do it in green. No, I won't do it in green. Let's do it in red, because red is usually displacement color. So then the very final vector, so the resultant vector. So remember, when you're adding two vectors or subtracting, either way, we call these the components. So this would be the vertical component, and this would be the horizontal component. And the actual component that you end up when you add those two, we call that the resultant component. So the resultant component, we don't know what it is. So if we use the Pythagorean theorem, which is a squared equals b squared plus c squared, so where a squared is our hypotenuse and b squared and c squared are the two different components. So a squared is our resultant and these are our two components. We want to find out a squared. So in order to actually just quickly rearrange that, to get a, you need a square root of all that of b squared plus c squared. So in this particular example, we have, let's put that in red, square root of 828, which is in purple, 828 squared plus c squared, which is 756.6 squared. Let's just complete this here. So if we do that quickly, Mr. Coombe's going to do that quickly in his calculator. Square root of 828 squared plus 756.6 squared. It should end up being 573.27 meters to the bottom right. Well, this might actually be going into my video, so we'll get rid of that for now, because we've already established that our coordinate system is to the bottom right, so we're going to be saying that it is to the bottom right. But the only thing that we don't know for now, okay, the thing that we don't know is the angle at which it actually is on the bottom. So we can calculate a couple of different things. Okay, a couple of different things. We can actually calculate this angle. Let me get the red pen out. We can calculate this angle, which is going to be the angle to the horizontal. But remember, we want to actually calculate it from its origin. So this is its final destination. So we want to calculate it from its origin. So we could calculate this particular angle, and that will be the angle in relative to the horizontal. But usually you want to calculate the angle from the horizontal. Okay, so how far down in terms of degrees did it actually go? We can figure that out pretty easily using our trig functions. Our trig functions, just so I'll remind you guys, is TOA. Okay, so we can use any of these trig functions because we have all three of our data now. So I would, for now, let's use our original data. Let's use the original data in order to figure out the actual angle. So let's use this particular trig function. So we know that tan theta, so here we're actually going to use, for now, we're going to get this angle, okay, this angle, tan theta equals our opposite, so that the component that is opposite to that angle is 756 point, so let me put that in orange, 756.6 divided by the adjacent component, which is 820, oh that's not the right color, which is 828. So let's get theta. So theta, so if we get the inverse tan of both sides, we will get theta on this side, and we will get inverse tan of our expression, 756.6 divided by 828, which should give us a value of, let me do it real quickly, so inverse tan of 756.6 divided by 828 should give us an angle of 42.42 degrees. Now that is this angle here, so 42.42 degrees. Now we can actually use a little bit of common sense in order to actually figure out these other angles. Now if you have a look here, this complete angle here should be 90 degrees. So to figure out this angle, you just take away that angle, 42.42, away from 90 degrees. Oops. Which is going to be 47, and let me put that in, let's say green. So this particular angle here is going to be 47.58 degrees. And in order to get this angle, because we know this is going to be a right angle, okay, so that's going to be 90, we just take away, so the total angle, when it's a right angle triangle, the total angles inside needs to be 180 degrees. So this is also here, so this is also going to be 47.58 degrees. So that is our final angle. So it'll be 573.27 degrees to the bottom right. at 47.58 degrees to the horizontal. So that's the answer, and in the next video I'm going to be figuring out and helping you figure out the final velocity at which it actually reaches. So hopefully that was helpful, and we'll see you for the next video.